So welcome to the Digital Twin Talks by the National Digital Twin Programme. Over the last 4 weeks, we've heard from experts across industry on what underpins digital twins and why they're important to us. So today we bring together these experts into a live roundtable hosted here on the Digital Twin Hub. So I'm Simon Evans-Samarup, and I'll be moderating this roundtable where you'll have the opportunity to take part in the conversation and ask those challenging digital twin questions. So this is a Microsoft Teams live broadcast. It's a one-way audio broadcast, so there might be a slight delay between you speaking or us speaking and you receiving it. And if you want to ask questions, please use the Q&A feature that should appear on the right-hand side of your screen. If this panel isn't displayed, please move your mouse over the center of your screen and you'll see a floating bar appear and there'll be a conversation bubble you can click on. So when you ask your questions, you can either enter your name or use them anonymously. And once they're submitted, our team here from CDBB will publish them for the other listeners to see and for us to answer. So we'll try and get to all of your questions, but if we don't do so, we'll continue the conversation on the Digital Twin Hub afterwards. And finally, if you're on social media, please share your views using the hashtag Digital Twin Talks during this. So I'm joined by our 4 experts at the moment, and if you didn't see their talks over the last couple of weeks, you can watch them back on the Digital Twin Hub. But to recap and introduce them quickly, in week 1, we had Olivier Theroux, Head of R&D at the Open Data Institute. He shared the ODI's research and perspectives on moving towards a web of digital twins. In week 2, we heard from Dr. Brian Matthews from the Science and Technology Facilities Council. He spoke about some of the technical challenges of creating an ecosystem of connected digital twins. Then in week 3, we had Dr. Tanguy from IMEC in Belgium. He introduced their digital twin program and how it's being applied to the public and private built environments. And finally, last week in week 4, we had Neil Thompson from Atkins, who's also the delivery lead for the Commons workstream of the National Digital Twin Programme. He introduced the Commons, which, as the name suggests, is developing the common language and framework for connecting digital twins together. So digital twins, they mean many things to many people. Some see them as a technology or product, while others see them as a methodology, an approach or way of working. Now, however you view digital twins, it's fair to say they're probably here to stay, and they're going to make a dramatic impact on society, the economy, and environment. Now, of course, digital twins are exciting, but when you start connecting multiple digital twins together into an ecosystem, that's when it really gets interesting, which of course is the objective enabled by the National Digital Twin Programme. So we have our 4 experts on the call with us here now, and we're going to start the roundtable discussion. As I say, please use the chat window to ask your questions to us, and we'll get round as we go through the conversation. So the first question here, Neil, is to yourself, and it is digital twins. They're a concept that's been around for quite a while, but something new in the built environment sector. So we first saw it in the aerospace sector, and prior to that, probably come into the oil and gas sector. But what do you think makes it really different for the built environment? Or is it just an evolution?
Yeah, thank you, Simon, and hello, everyone. It's a good question because I'm torn. I think there's 2 answers to the question, which is probably not useful. I think the first one is about language. I think they've been around in the built environment for a long time as well, but we just didn't call them digital twins. I think there's an evolution of the language, and that evolution is, I can talk to somebody from somebody from Rolls-Royce, for example, intelligently about the connection of data through from a product into a service, for example. I think the other side of that coin is also around the difficulty of applying technology in a sector. So when you're applying an information management framework to a product, a specific thing, like a jet engine or a pump or whatever, that's relatively straightforward in comparison to using the same framework to apply it to a building and its contents and the people within it. These I guess the built environment is the human interface with some of these technologies, and that human interface makes the application of technology quite difficult. And lastly, the huge and fragmented nature of the market means that we've never really had a need to tie the information together properly before. But with all the industry reports that have happened saying about the dysfunction in quality in the delivery process and the need to communicate between people from a contractual perspective, we're now in a space where we need to tie that information together to achieve superior quality outcomes for the end users and owners and operators, etc.
I fully agree. I'm not sure, Brian, from your perspective, what's Daphne's view on if this concept's new? or if it's just an evolution from technology in the past?
I think there is an evolution. Certainly, we've seen the techniques that underpinning digital twins being developed for many years. What's changed from a computing perspective is the ability to scale up, the ability to collect large volumes of data, the ability to then provide new algorithms, new techniques on that. We all know about the AI revolution, and that's sort of the driver behind this. And I think to handle that complexity that has been mentioned just now, it's complex enough. Well, managing one model to manage kind of multiple models all at the same time, I think is a real challenge. I guess that is quite new in itself. I don't think we've really managed to tackle that challenge completely yet, and I think that's a really exciting research area for us all.
That's interesting to hear, and I think there's a lot of excitement with this concept at the moment, isn't there? And we've actually had a great question come in here from the University of Kent, actually. So Tanguy, I was wondering if you could take this one for us, which says, how are digital twins different from other digital technologies, such as AR or VR, or dynamic simulation tools, such as finite element analysis, which are able to provide real-time scenarios? I thought that was quite interesting because of the Buddy platform that IMEC are working on.
Yes, good morning, and thank you for this question. Yeah, from the perspective of AR and VR, well, at the moment, what we are working on from a city perspective, so a lot of the work we do is to look at how you can support decision making in cities. We actually do not use AR and VR at the moment. We use 3D models. So there is like a lot of interconnection between AR and VR and the 3D world, of course. But the interface that we focus on mainly is a web-based interface. It's a 3D web-based interface, which does not say that in future iterations of digital twins, it would be useful to have AR and VR based twins. And there, I believe it would be interesting also to take a look at in situ, let's say, ways to expose data in a digital twin. And by this, I mean that you would be standing at a certain location in a city, and you would be able to see a number of things around you that would augment your view of reality, which is typically what you do in AR. So I think AR is really very promising. It's going to surely appear on the same roadmap as digital twins, but at least from our perspective at IMEC, we are not there yet. We are first focusing on web-based interfaces. And then for your question on models, so the platform that we are working on is really a way to connect models, to do also simulation, but mainly to be able to interconnect these different types of simulation models with a digital twin platform that over time would be able to work together with different types of models. So I think the ones you mentioned are for sure interesting and relevant, and we are looking at interconnecting these different models, making sure that, for example, they can reuse each other's output.
Yeah, I think to build on that, it's a key thing that I like to keep in my mind is the two sides of the digital twin. There's the human interface with the data and the decision making process, or humans doing the things that computers can't do very well space. And then there's the machine to machine piece, and being completely clear about the the design of those two spaces, are very different. And I think when we talk about the frame, don't say hierarchy, but I guess use Simon's phrase of the spectrum of the application of the digital twin at one end, and this is sort of the space that we're in now. And if we think about the traditional application of technology, we've tended to deploy technology to augment how we did things previously. We don't seem to be very good at reinventing the process to suit the capabilities of the technology. So I think there's the human interface. I think some of the that AR VR piece is important, but I think is only a very small piece and a very small window into a broader piece of technology. I think and I guess to make this example real, let's think about what's happened with the internet. It started off as a place where we visit websites, and if we look at if we look at internet traffic today, that internet traffic of people going to websites is very small in comparison to the data streaming services. So if you think of the Spotifys, the Netflix, and what have you, we've moved from this place where we visit websites around the world on the internet to consuming data services. And I think the digital twin has that consideration as well, which hopefully links back to what you're saying there about the human interface, but then there's also the machine to machine piece as well.
I think that machine to machine piece and that interoperability question is quite an interesting one, which leads us to one of the other questions that I was going to ask yourself, Brian, is as the built environment becomes more digitally enabled, it has to have it will face more challenges around data security and data interoperability. With digital twins needing more data more often, how will security and interoperability challenges be addressed?
Well, I was going to start with the interoperability challenges. So here, I think what we've seen already on the Commons is actually very important. But the challenges, to me, seem to be on two levels. One of which is sort of we need to combine data from different domains. So we've got different areas we need to work with, different buildings, different organisations, each different sectors, each with their own standards, each with their own language they need to talk in. So evolving that language, evolving that common platform to talk to, so data can be moved around and interchanged, I think is vital. And so therefore we need to have common semantics, common standards there. The other thing I think is to recognise that if we're trying to interconnect twins, that different twins at different levels and different sectors work at different paces and different granularities. So we need mechanisms whereby we can aggregate data together or map between different granularities of data or different temporal granularities. So we have a project with the University of Oxford called NISMOD, which is trying to build together energy models, transport models for regions, and in the process of joining those models together, will transform the data from one sector to another. So a model that's working at say an hourly frequency can interact with a model that's working at a model that's working at a daily frequency, for example. And so we need to both aggregate data together, but also interpolate data backwards. So those techniques are, if we're really going to build twins together, those techniques need to be very common. So that's kind of interoperability. Data security, I think, is quite a different thing. I think we'll need to learn a lot of lessons from, for example, the health sector to see how they do that. I don't know if anyone else would comment on data security.
Yeah, I was wondering actually if we could add, because off the back of that, data security, particularly interoperability as well. I know that's a big part of what the National Digital Twin Programme are looking at, particularly in the Commons work stream and the information management framework. I'm wondering, Neil, if from your insights into that program, how that is challenging, or how is that addressing the challenges of interoperability and security?
Yeah, I guess there's it's a tough one to answer because one, we work very closely with our security services, and unfortunately there's certain things you can't talk about on public platforms. So I guess one of the things that we need to make sure that we know is that these things are in hand with the appropriate people and are being watched, and guidance is being created. So what we're doing in the Commons is like what we did. We've created a pathway for the information management framework, which should be published very soon. We're also doing the same and in progress with a pathway document for security. So working with the CPNI, for example, to work on those. How do we become security minded about sharing our data? And I think it's in that world it boils down to being security minded. Unfortunately, when you're placing your data sets together, you do have to think about how can this be used maliciously, and having that mindset about how you'd be proactive in trying to tackle that, and also making sure that you have strategies in place when you start building these about who has access to them, how they have access to them, and how you revoke access, and roles and purposes around that.
So it's security minded from the outset and
Yes.
intrinsically linked throughout it. And I think that's important, isn't it? Because we see breaches always mentioned on the news, even one just over the last couple of days from a large organisation many of us have used, and we need to have that consideration from the outset.
And just on top of that is also the even when we have lots of different types of data sets, the triangulation of those data sets is very powerful. So it's not just for example, an organisation leaks some rough details about a particular asset that shouldn't cause any harm, but the issue is that you don't know what happens if it gets triangulated with other data sets. So it's not an easy space to operate in.
Yeah, absolutely.
And one which again, I think that the health sector in particular, so there are definite lessons to learn from there, who are very exercised with those what might be inadvertently revealed by that triangulation. So I think we need to make sure that we talk to parallel sectors that we're working with.
I think that's a really valid point, particularly when making the business case for why digital twin, because often people see it as this aspirational unicorn, this thing at the end of the tunnel that it's very difficult to get to. And the proof cases of the immediate questions you can answer here and now are what helps you build the business case. So Tatangi, I've got one for you. If we were looking at, let's say, property developers as a sector, this is one of the questions that's come through, how would you define the business case of using a digital twin and then link it to BIM if you were speaking to, for example, property developers, but also other sectors as well?
Well, for property developers, this in itself has not really been a market that we have looked at for the moment. We are mainly working with cities and city governments to support, well, the type of questions they have at the moment, mainly looking at mobility and air quality. So these are not really, I guess, the topics that would be really interesting to property developers in cities. Although, well, if it's about building companies, there we have been talking to a number of companies that are doing big public roadworks, for example. And there we really see that there are a number of interesting use cases. Like, for example, if you're going at the moment, Antwerp is set to be the biggest, let's say, construction site in Europe, because we're building a new type of ring road. And there we're getting a lot of questions on could you simulate things like drilling works? So if you do a lot of drilling around the city, will this damage certain buildings, certain other buildings? We're also getting questions about air quality, and we're getting questions about noise pollution caused by these works. So there is a lot of movement around like what type of impact does doing public work have on, well, the society where you're doing it in. So what's the impact on the city? So these are the types of use cases that we see, although they are not really linked to or directly linked to property developers.
And do you think there's a difference in perspective, Tanguy, for how Belgium are approaching it, maybe as to the UK? I know that's maybe not a fair question if you don't know what the UK are doing in detail, but has Belgium got a particular slant or focus within their views on this?
Well, Belgium at the moment is really looking at what digital twins actually can deliver in terms of value. There is a lot of movement in the building sector, so we're really seeing a number of actors that are trying to work out what type of system they could build that uses digital twins. And I think there at the building level, you really see some commercial activity that tries to focus on building also this kind of like digital twin platform that would be extensible, in which you could plug in different types of models for different types of challenges. It's a little bit like what we're trying to do at the city level. You really also see this happen at the construction level. And for the rest, we really see in Belgium that there is a lot of, let's say, regional movement on, well, working out exactly what are the business cases. You mentioned business cases earlier on. So we're really at the moment where a lot of parties are having a lot of conversations about what would be the best business cases for applying digital twins to. So I'm not sure whether in the UK you're already past this stage or you're still struggling with the same types of questions, but this is where we are in Belgium for the moment.
It's interesting to hear the different perspectives, because yeah, here in the UK, absolutely, we've got absolute support from the UK government on what we're doing with the National Digital Twin Programme, which is great to see. We've got that top-down support. And that's been really beneficial in getting traction with the programme, getting people wanting to take part in it, and also, of course, progressing it at pace. So it's been really exciting. So I've got a great question that's coming to yourself, Neil, that's come from Carolina from National Grid, if that's okay. So the question is, so digital twins are meant to be representations of complex systems. So to use them effectively in simulations/models, you need to be able to integrate them properly with human behaviours and interactions. Has anyone out there been working on simulating market behaviours and economic utility functions to provide input into digital twins to best study outcomes? So as an economist, I know you'll come quite along with this question.
Yeah, it's a good question. So you know, one of the things that I study with my sort of UCL hat on is microeconomics, and this is sort of one of the holy grails of where we're trying to head. And if we, one of the pieces of work that I'm aware of is there's a thing called a personal information profile. Is essentially the currency of your personal information on the internet. So all these quotations of $9 per user for a social media company is where these things come from. And I think there's the extensibility of that personal information profile into the built environment space. If you think about the metadata that's collected through your mobile device, it's no longer just where you go as an internet service provider and the things that you're interested in. And you looked at barbecues once, so Amazon's going to flash up barbecues for the next 3 weeks. There's another layer of detail in the metadata for your personal information profile from your mobile, including location, temperatures. There's cameras that can look at on the phone that can look at your emotional state and what have you. So we're reaching this sort of richer level of understanding about people. Now, we'd have to consult the Gemini principles in terms of how we use those from a moral perspective, but there is work happening about modeling at that level. I think what isn't happening is that connectivity of human behavior into the built environment. There was a few years ago, I don't know if you remember the in the news about the bins in the square mile in London that were counting the pedestrians going past, and they were somewhat rejected by passers-by. So I think there's this acceptability of users to be measured in that way. So that's something to overcome. I think in terms of abstracting that up into the market, that's an even bigger step. But I think an interesting thing here is that we've got existing technologies that can be mapped into the built environments. If we look at the consumer platforms for buying products, you know, the likes of Amazon and what have you, and how they're driven by ratings of users. I mean, the jury's out on how effective and how truthful they are, but if that was mapped into the performance of buildings, infrastructure, products within buildings and what have you, it will create an interesting market platform. Because from my point of view, when we're designing infrastructure, we're essentially building the future market platform for things to be procured upon, and rewiring that market would have an interesting impact on our behaviors, both within the industry and how we collaborate with each other, but also how infrastructure will sit in the broader society. So it's certainly an interesting question. I know that there's people looking at the extension of personal information profiles through internet technology, but I've yet to see an example where it maps across into the deep behaviors that we need to understand to design infrastructure in a different way.
Brilliant. Thanks, Neil. That's good answer. So I've got a great one here that's targeted for Brian. So one thing we can all agree on is data is inherently imperfect and is often not represented effectively in traditional modeling. Is this something that Daphne will be able to help with? I think you're on mute. Sorry again, Brian.
Muted now? Yeah. So I could repeat the question. I was just.
Of course, absolutely. So the question is, one thing we can all agree on is that that data is inherently imperfect and is often not represented effectively in traditional modeling. Is this something that Daphne will be able to help with?
Well, I think there's two aspects there, isn't there? There's fairly imperfect in the sense that you've got missing data. You've got data that's not. You haven't got it, so you have to get it from somewhere else. So there's a notion there of a place to bring data together. So I think that's something we would seek to provide, a place where you can provide a hub where you can either share data in one place, or as I see it, a sort of data exchange where you can find data elsewhere which is of relevance to your question. So, and again, relying on those interoperability standards so that you can share it, you can find how to access it, you can see what conditions are applied to it. The other aspect is even if you get data, you need some measure of its quality, and that I think is perhaps a much more difficult question. Measuring the quality of outcome of data is actually inherently quite hard, and no matter what kind of systems a central place may be able to provide, measuring the data, the quality of data is often very subjective. So there, but again, perhaps a sharing environment could help, where you get feedback on data because it gets reviewed and you get that citation aspect. Good data tends to get used more than bad data. So yeah, in the sense of providing a central hub, I think it could be a very useful role.
So on that question particularly, then, does it mean that transparency is more important than quality when it comes to data?
Well, sometimes getting any data at all can be better than getting none. But I think you have to make sure you take account of your error bars here, and and recognise that you know, imperfect data in leads to imperfect results, and you have to recognise that the results you get only have some, you know, are of lower probability of being what you want, and I think that needs to be accurately reflected right through the ongoing results of the model.
Brilliant. Thanks, Brian. I've got a great question here for yourself, Tongi, around COVID-19. So this is going to be obviously quite a topical one. I think Neil's probably got some stuff to add to this afterwards as well. So with COVID-19 restrictions relaxing, obviously country dependent, our economy needs to restart with a social distancing paradigm. If an organisation has a digital twin which is monitoring the flow of occupants, for example, like within an airport or within a building, how could that digital twin support social distancing?
Yes, so this is indeed something that we are looking at for the moment. One of the models that we are working on to, let's say, visualize and expose through the digital twin platform in cities is it's a data fusion model that looks at different, well, data sources that we can get from, for example, telecom operators that can give us data on, let's say, an aggregated level of, let's say, a block of, I don't know, 50 by 50 meters. How many people are there at a certain location? So we really have a lot of these data sources that can provide us with some pieces of a view of a city and where people are actually moving to, and we then are, let's say, injecting them in a model. It's a hydrodynamical model, like it kind of mimics how a liquid would be flowing through a sewage system, for example. And we are looking at how people are moving all over the city. So from this we get densities of well, how many people are going to certain locations, and we're getting a lot of questions from local governments that really want to look at, well, what they call, for example, for the moment, crowd control, which is maybe not the nicest term, but there is a lot of buzz around that, and we're getting a lot of questions on how to monitor these type of people movements in a COVID-19 world. Also, there are some efforts underway to also do evaluations of social distancing based on camera data. So there are already a lot of CCTV cameras dispersed throughout cities. For our research projects, we have access to some of these through contracts with the police. Of course, there's very big privacy issues there. And we're also looking at how to, well, identify these social distances and whether people are respecting them at certain places in the city.
Yeah, and I guess it is a great, the COVID recovery response is a great place for us to think about the different building blocks of a digital twin, because there's one, the digital twin that creates the boundary conditions of the thing that you want to ask what if questions of. Then there's the ability to ask the what if question. So the what if question here is, are people not committing to social distancing? And then there's a, well, how do you deal with that and how effective was it? And it feeding back into the system. So those three steps. So the less sophisticated part of the twin is the how do you create your boundary conditions. Now those boundary conditions don't have to be 3D geometry. You know, it could be an XYZ coordinates on a well, I say XYZ, XY coordinates on a 2D plan, up through to different abstractions of reality, through to, well, how do you ask the what if question? Is it something that's measured automatically? Is somebody sitting in front of a CCTV screen looking at people and pressing buttons to say, oh, people not social distancing? And then, well, what's the intervention? You know, so what? You have an answer that says these people aren't socially distancing. What are you going to do about it? And I think it does demonstrate sort of those three steps of, you know, how do you create the boundary condition? how do you ask the what if question, and then what do you do with the answer? And I don't think we really know what to do when people are not socially distancing. Are we going to, you see things on the media about different countries, people prodding each other with sticks all the way through to firing loud sounds at people, and I'm not too sure what the answer to the question is, to be honest. And sorry, that's not useful, but I think that okay, your digital twin's given you an answer to a question, then what is an interesting thing to think about, especially in the context of what we're trying to achieve here.
Absolutely, and it's about again back to the use case, isn't it? And the one line I like using is that a digital twin is very much a journey and not just a destination. It can do things along the route and answer questions along the route. And that's actually quite interesting, because that goes nicely to the next question from Martin. So Martin, you've asked, there is a lot of focus on the benefits of digital twin during the operations and maintenance phase of the asset life cycle. Does the panel see there's equal, less, greater or more benefit during the design, build and decommission phases?
Shall I take that one, Simon?
Please.
So I think there's one of the things that we're doing in the National Digital Twin Programme is trying to shift everyone's view from starting with design to starting with use and operation. So that focus is because you have to start with something in reality, and that operational asset is either a field in the middle of nowhere all the way through to an operating train station. So that's always your starting point. What the benefits in the design phase is that you're able to simulate your let's call it the intervention against that existing thing with a better level of intelligence than previous methodologies for creating design. If we think about how a lot of projects get off the ground, it's generally not from creating a rich evidence base, placing the asset within it and simulating the permutations of its behaviors, both as an asset as a physical thing in its environment, but it's also going back to that human behavior aspect, is how do we invite future users to that space to see how they work. I mean, I know that we've done that, but we've not done it in a way that gives you a rich enough experience to give you a tangible result.
I think that's a really good point. And I wonder, Brian, from a Daphne perspective, if you're seeing that there's use cases across the life cycle, so in the design, build and decommission phases, or if most of it's still in the operations and maintenance sense.
From our point of view, most of the use cases that we've been looking at are not so much in the decommission, but certainly in the planning and design stages. So that's perhaps been where our main focus has been. So to give a simple example, we have a case study with the University of Southampton, which has been looking at planning for railway stations. So if you place a railway station in an area, where is the best place for that? How is it going to affect how the population uses it? What's the kind of average distance that people would have to travel to use that railway station? To get them to maximise the footfall, and also to minimise the kind of the resulting decrease in footfall on other stations in the district. So very much looking at the planning and design phases of the system. The NISMOD example that I mentioned earlier is looking at the impacts of opening up transport links between Oxford and Cambridge, or improving contact links. And again, where do you plan to build towns? Where do you plan to site businesses? What kind of facilities do you put along that route to again maximise the economic and social benefit of that improved transport link? Going back to COVID-19, I think there are huge numbers of potential examples where this may come up. So an area that I don't think has been mentioned is how the design of the environment would affect that social distance. How would it affect this future transmission of the disease? So how building design and building density would or would not encourage transmission, how street plans, which concentrate people in certain places. They may well be hotspots for disease which you may want to avoid or reroute people away from. So I think personally, the benefits in operation are huge, but the benefits in planning are equal, at least equal to that. I mean, we may improve operational costs in the first place by improved planning and design.
That leads nicely actually onto yourself, Tanguy. So do you see digital twins as a tool to support planning, or do you see it as an output from the planning phase?
Well, for us, the main applications are indeed to look at interventions, and so to plan certain interventions, and then to see what type of interventions are simulated to be the most effective ones, and then of course to find out whether they have really had this effect. So in terms of COVID-19, for example, it would be about having different types of approaches to engender social distancing, and then finding out which one has actually been most effective by looking at the result. So I think also this kind of feedback loop is really very important. So we're really looking at making sure that the stuff that is being predicted by models can also be validated in some way. And this is not always the way in which some of the models that we are working with are operating at the moment, because some of them make predictions, because they're built on let's say modeling the underlying processes of a model using differential equations and these kind of things, but they do not actually validate the predictions that they make. So I think for us, it's also, I mean, one of the things we're researching is really about like how to integrate this feedback about like, okay, you plan something and then you make it happen in real life, and then something changes in reality. And then what can you do with the data that flows back to make sure that next time around your predictions become more accurate, let's say. So for us, it's definitely in the plan phase that we see most activity.
Brilliant. Thanks, Tanguy. And to all our listeners, I'll remind you to please use the chat window on the right-hand side of your screen to ask your questions, and they'll come through to us here, and we'll read them out to our experts. So we've got quite a large number of people online, so hopefully you're enjoying the conversation. So another one here, Neil, going to yourself, particularly in relation to the National Digital Twin Programme. The question is, what type of entities or entries do the Commons want in the glossary, which you talked about last week? And how do we expect the glossary to be used by the wider National Digital Twin Programme in the future? And building on that further, and how can people contribute to it?
Thank you. Good question. So let's deal with the latter part of that, of how to get involved. Getting involved is easy. I have to double check the URL because I'm not trying to check. It's digitaltwinhub.co.uk. Is that right? Yep. Again, thumbs up.
Digitaltwinhub.co.uk. That's correct.
That's correct. Thank you. So head over to there. You can use the glossary for free, and without being a registered user, you can go and check it and look at it. But that's all you can do. What we want people to do is to register for an account that will enable you to participate in the commentary around the glossary, and it can also allow you to be part of that feedback process that we've created. So, which gets to contributions and what we're looking for. So, at this moment in time, the glossary is about building the landscape of the language first. We're not looking to tie down what the language is really quickly, because we feel that this is an emerging landscape for how we communicate these things. So first phase is about capturing all the language that's out there. Doesn't matter if there's duplication, because what we can do as we work through and as people contribute, we can work out which modes of language are more effective, which modes of language are more specific about particular things. The language around applying digital twins for a oil and gas plant may be different to how you apply it into a school, for example. But how do we know the difference between those? So as I say, phase one is more loose and nebulous, and as time progresses, what we can do is start pulling out things that we is there I suppose is there any contentious is not the right word. Is there any we'll go for contentious. Is there any contentious issues around certain terms that we need to either influence standards to change or create new standards? And I guess that's the ultimate outcome is, do we invest in the development of existing standards, or do we need to go and create a new one? So that's sort of much further in the future, but right now we're just getting going. So the kind of things that we're looking for is, is there language that emerges that you feel that doesn't have a definition, or if there is one that you think is good and needs to be shared across other people, contribute that to the hub as well. So I guess to recap on that, if you come and register, you're able to provide feedback on existing ones, and you're also able to suggest new terms, and those suggesting terms sort of come in two flavors. They're shared ones, they're terms that come from other places or standards or organizations, and then there's emerging. So emerging would be, I can't find a definition for this anywhere. I think it's something that needs further work, and we can find a home or a place, or it could be developed here in the hub, for example.
Brilliant. Thanks, Neil. And yes, it's digitaltwinhub.co.uk/glossary, or just type in Digital Twin Hub into Google. And then when you go on the web page, on the left-hand bar, you'll see near the bottom of it says glossary, and go in there. So linking onwards into machine learning, which we know is often bundled into the concept of a digital twin, Brian, I'm wondering, how has Daphne seen the relationship in their pilot studies between machine learning, the data, and the concept of digital twins?
So as yet, I mean, in relatively early stages, we haven't actually seen a lot of machine learning done yet. I guess it's an area which when we get more experience, more data coming through, we'll see a lot more of. Yes. I need to think about it a little more.
Yes, it's the challenge, isn't it, of having the good data quality, because I'd often say that the term machine learning and even artificial intelligence in general has also become a buzzword, where it's thrown out on the table without, I think, full understanding of what was required, and that being data, in essence, of good quality.
Any data analytics tends to get called machine learning these days, or AI, or tech, or data mining. I mean, I agree with you there completely. A lot of the problems around AI are actually around data interoperability, data gathering, data interoperability. And around sort of data selection, I think, which is an important highlight. Your machine learning is only as good as your coverage. So if the data you've got is poor or poorly covered, that question we had earlier about imperfect data perhaps is very relevant here. But I mean, I said from a Daphne point of view, I think it's an area we want to see more of and see more experience in. For looking at the algorithms.
And yourself, Tanguy, when it comes to machine learning, how has IMEC and the Buddy platform been looking at that? Have you been seeing a big, what's your views on machine learning and how it interacts with the digital twin concept?
Well, Yeah, I think as the digital twin that we are working on, it's like an extensible platform in which you can plug in different types of what we call solution accelerators, which are then defined as a combination of like one or multiple data sources, a model, and an API. The modeling component there, of course, is where machine learning fits, and there's a lot of modeling that we use that does not really have a learning capability, so that does not really learn from making predictions and then finding out what the errors are with relation to these predictions, so they do not improve over time. But we believe that there is a lot to be gained from well, putting machine learning as a first-class citizen in these digital twins. And what we mainly have been looking at is computer vision on camera data in cities. As I said, there is already quite a lot of cameras out there. So what about being able to analyze this data to, for example, just identify how many people are moving around in a street? And there are then a number of technical challenges to look at. A lot of what we do is about edge and extreme edge computing. And so this means making sure that not all the data needs to travel to the cloud platform in order to be analyzed, but that you can also have algorithms and compute platforms that are associated with it that live closer to the sensor, in this case, the camera. Another area that we've been looking at is about air quality and doing interpolations of well, air quality maps, let's say. So the classical way of doing heat mapping for air quality is having a small number of very expensive and highly calibrated air quality sensors that you can only put a number of them in a city and then build an air quality map around that. But I mean, this only has, let's say, so much accuracy. What we've been looking at now is having more air quality sensors that are driving around a city that are cheaper, that drift. So there is a reason why they're cheaper, is because they have lesser accuracy. But what can you do with this cheaper data to also build an air quality map, knowing that you have a number of really highly calibrated air quality sensors that are already there in your city? So could you drive past one of these air quality sensors and then recalibrate the other sensor? And what kind of machine learning algorithms can you apply to actually learn how to do interpolation of air quality maps? And so we've been seeing that there are a number of technical challenges that exist there, also a number of opportunities to innovate. As I said, we're looking a lot at edge and extreme edge computing, but also stuff like machine learning ops. So when you have a machine learning algorithm, you build it, you train it, and that's all nice. But then you also need to deploy it and make sure that, well, let's say it remains sane. So you really need to monitor it and retrain it also from time to time. So training your algorithm is not just a one-off thing. It really needs to be taken into account how you're going to fit this into your operations. And then in terms of selection, so there's a lot data selection, which was also hinted at, I think, by Brian before. We're also looking at ways to selectively label data. So doing things like active learning to make sure that when you have a big data set, so the most common machine learning approaches these days, they are about supervised learning. So it's about learning by example. And for this, you need a lot of labeled data. And active learning is about being smart in what data to label and what not to label. And you're only going to label the data that will bring the most value to your algorithm. Because labeling data can be very expensive. You very often need to have people label data. So being able to do that in a smart way, I think, will also be an interesting addition to digital twin platforms.
So it's a really good point, and I think that really highlights the aspect that there are many kind of technologies and facets that make up a digital twin. And I know the Institution of Engineering and Technology published a white paper just last year on digital twins of the built environment, which contains such a model, the maturity spectrum, which I know some of us in the call have looked at before, segmenting the different elements that make up a digital twin. But I thought I'd go over to yourself, Neil, for a question from Bentley. So the structure, classification and definitions of assets and related asset information, for example, digital twins, is key for enabling better decision making. How do you believe the commons approach will help expedite a common national digital twin approach in these areas?
That's a great question, and you sort of set out the difficult task that we've embarked on. And I think from my talk, an important concept for us to keep in mind here is that there's a difference between a consensus mechanism on how we agree to do things and standards. What we didn't want to set out to do is we're going to go and create a load of standards that you're going to have to follow. No argument, which we know isn't going to work. It's about that consensus building. So the commons is about that, surveying the landscape, using an evidence base against what works, what doesn't work, why it works, why it doesn't, and progressing the conversation through there that will then bring about consensus on, well, we're going to do these things because they work. Now, through that consensus mechanism, we can then move forward into standards. And I guess, I'm not going to give a lecture on the history of the creation of the internet here, but for those that are interested, there will be a blog post coming out soon on the DT Hub about that and how those consensus mechanisms and the creation of what they call internet culture, so this sort of open source and flatter hierarchies around bringing consensus before standardization are really key. So that's a principle that we want to carry forward here. So we need to agree that, and in the information management framework pathway paper, it talks about the difference between a structural beam and a laser beam, and we need to be completely clear about the difference between the two, because if we get those two things mixed up, we're going to be very confused. And look out for that paper as well.
That's brilliant. Thanks, Neil. So we're coming to the end of our time here, and what I'd like to do is firstly go around each of the speakers and really ask them what they found most useful over this series, particularly if looking at some of the other presentations that happened over the Twin Talks from each other. What did you find the most insightful? So maybe I can start with yourself, Brian. Sorry, I think you're on mute again, Brian. There you go.
So I think for me, it's been really useful to just really think about what it means for what a national digital really means. This ecosystem of twins that we've been talked about. What does that really require to actually make that real? It's a very ambitious aspiration, but to actually make that work on a technical and organizational level is incredibly complicated. I think that the emphasis on data and data sharing and data interoperability has been very good to see, and to keep that as a decentralized approach, which is about building consensus and building and sharing standards, using systems like Daphne as potentially sharing spaces or pointers to elsewhere. I think that is all crucial and really interesting to see, and to see the different sectors and scales and that need to be brought into that. I think has been, that's my main takeout.
Brilliant. Thanks, Brian. And to yourself, Tanguy, what have you found most useful from this series of digital twin talks? And was there any parts of the other speakers which you found really inspiring or most interesting?
Well, to me, it's been very interesting to see that there is really a community around this that is emerging in the UK, but also at the international level. There's also a couple of other initiatives that are taking place in different places, and I hope that we will have a lot of interesting conversations. I've especially been very interested in hearing about everything that has to do with defining digital twins. What are they not? Hearing the different interpretations that exists. Also a lot of talks about the semantics of it, the types of data standards that we need, the ones that already exist. Also the ones that exist in other sectors are also very useful to know about. I think also standardization at the data level, for example, is not something you can do at a local level, especially Flanders, where we work from, is way too small to take this up. So to us, it's really very important to see that there is an international community around this and to have a discussion about standardization and semantics.
Brilliant. Thanks, Tanguy. And finally, over to yourself, Neil. What have you found most interesting from this series and what's inspired you?
Yeah, I guess the most interesting thing and the inspiration rolls into one for me. So it's one that we've embarked on the journey. We're not. This series hasn't been about here's some crazy plans you want to come along on the journey. We're further along in all our cases. We've been given examples of things that we've been doing and inviting others to come along and join in the journey, as it were, as you say, Simon. So I think inspiration for me is across all of them actually is some tangible examples of things that we're doing. And I think for those watching, if you're thinking about your digital twin journey and you haven't moved from the slideware and the thing, having architectures on PowerPoint slides, and you've not moved into those tangible proof of concepts, you're falling behind. Come on, let's get going with at least some experiments and tangible things to show each other, because then that will give you something to come and participate with on the hub, which I think is great. And I think lastly, and especially with Daphne, and I think this is a key thing here, is that in some areas we're cutting new ground, but in a lot of areas actually we're looking at how, for example, we've got the research community and how data gets moved around. I mean, the data in the the scientific community is huge. They can move and simulate petabytes of data. And that's an aspiration for the built environment at this moment in time, and we've got lots of places that we can learn from. So it's not a hindrance; it's actually a great opportunity for us, because there's loads of places that we can learn from and pull inspiration from.
Oh, that's brilliant. And adding to that as well, I guess there's some more work happening at the moment, isn't there, around the FDM and the work that's happening in the Commons. I wonder if you could quickly say a snapshot of that before we end in the next couple of minutes.
Yeah, so the next step for us is that we need to create the FTP and the HTML of our digital twin world. So, what are the protocols for us to communicate with each other, not on just a human-to-human level, but more importantly on that machine-to-machine level? How can we create these structures to enable the, we spoke about the airport and the COVID response stuff. So we talk about, how can we describe our boundaries, the what ifs, and the answers to those questions digitally is a key step. So the information management framework coming through from the pathway paper is going to be a key step for us next.
Brilliant. Thank you. And that quite nicely in the ending part there answered Andrew's question from Northumbrian Water about which sectors and organisations are the most advanced. So I guess we're seeing a bit of a spectrum, aren't we, where some sectors, manufacturing, aerospace, who've been in this for a lot longer, with of course Apollo 13 being one of the first examples we saw of digital twins, they're much more ahead than other parts of the built environment. But the key part is there is a journey, not just a destination, and you've got to get on that journey now and don't fall behind. So thanks everyone for taking part in the conversation. Thanks for your comments from our panelists, and of course, an apologies from Olivier Theroux, who had technical challenges and wasn't able to join us today. So that concludes our roundtable from the Digital Twin Talks. Thank you for joining us. We have another series coming up next, or coming up soon, around the complexities of integrated digital twins. So I very much encourage you to take part in those conversations as well. And again, use the hashtag Digital Twin Talks. So all of these sessions plus this roundtable will be recorded live and then hosted on the Digital Twin Hub. So if you haven't joined that community already, I encourage you to go over there and take part. So again, thank you to Dr. Brian Matthews, Dr. Tom Gee, Neil Thompson, and Olivier Theroux for joining us. And thank you for everyone for taking part. My name is Simon Evans, and have a good rest of the day.